Hi class, this is lesson 10.1, use properties of tangents. So before we start this, before we start talking about tangents, I should say, we have to look at our different parts of the circle. So this first part, identify the parts of a circle. Keep in mind a circle is a shape where all the points on the outside are equal distance from the middle. So the center, the center right here is point P. So my center is P. A radius starts at the center and is a straight line going to the outside of the circle. So this would be a radius that I just drew in here. A diameter is another word that you should already know, and it goes from one side of the circle straight across the circle and through the middle. Trying to make this go through the middle, and that is called a diameter. And you already knew that one as well. A chord is a new term. So a chord is a line segment that touches the outside of the circle in 2 points. So it touches the circle in 2 points. That right there would be a chord. And for some of you who are thinkers, you're thinking, well, the diameter fits that description. The diameter touches the outside of the circle in 2 points. The diameter is also a chord. But diameter is a more specific name for it, so we would call it a diameter. The next part, identify these parts of a circle. We have secant, tangent, and point of tangency. So a secant is a line that touches the circle in 2 spots. It intersects, I should say, the circle in 2 spots. So this line that I just drew in, that would be called a secant line. And then a tangent line touches our circle in just exactly one spot. So I'm going to say it's going to touch right here in this one spot. Try and accurately draw right there. That would be a tangent line because it touches in exactly one spot. And then that one spot where it touches has a specific name. Right here, that spot where it touches is called our point of tangency. And that's the spot right there where it touches, our point of tangency. So the example here says identify special segments and lines. So first it says tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent. And we'll first start with segment BC. So looking at it, segment BC is right here, and it touches the middle of our circle, and it goes just to the outside. So segment BC, we would call that a radius. And this circle, just so you know, we would call this circle C because we name circles based on their center point. You could also write that like this, circle C. So you draw a circle with a little dot in the middle, and then the C is the middle point of that circle. So those are 2 ways of naming this circle that we have here. The next one, segment EA. So E is right here, and A is right here. Now E is outside of the circle, and A is on the circle, so this is really a line or a segment that's touching in 2 spots. Since it's touching in 2 spots, but it goes outside of the circle, we would call that a secant. The next one, segment DE. D is right here and E is right here. So this is another line segment that is outside of the circle. It's only touching in one location. We would call that a tangent. Good idea would be to pause it and try the on your own. Okay, if you tried this, it should say use an example 1, identify the type of segment you would best describe segment AB with. So segment AB comes right here. Now it's a chord, but since it goes through the middle, the more specific name for that would be diameter. So that's the most specific name that we will use. Okay, so this next spot again should be not too bad, pretty easy for you. It says find the lengths in circles in a coordinate plane. So example 2, use the diagram to find the given lengths. So it wants the radius of circle A. So here's the middle, here's A, and all the points are 2 from this. So here's my circle for circle A. My radius would be from my middle to the outside of my circle, and that would be 2 units. My diameter then would be twice my radius, and that would be 4. It'd be all the way across the circle. The radius of circle B, well, here's B, and all the points equidistant from point B would be this circle right here. Point B is 1, 2, 3, 4 units. So my radius of B is 4. Oh, I meant to write 2 up here for A. I don't know what happened to the rest of my 2. My diameter of B is going to be twice the radius, so that is going to be 8. So you should pause it and try the on your own. Okay, so looking at this one, it says use a diagram to find the radius of circle C and the diameter of circle D. So circle C is right here. The radius is 1, 2, 3. So that is 3. The diameter of circle D, well, here's circle D, here's the center of D, and so here's circle D, and 1 goes just to the outside from the middle. That would be my radius of 1, but all the way across my diameter would be 2. All right, let's turn the page. Okay, so this next part says all circles can intersect in 2 different points, 1 point, or no points. So we're talking about coplanar circles here, circles that are on the same plane. And we're going to give some special names to these. Circles that intersect in 1 point are called tangent circles. Circles that have a common center are called what we say concentric. Concentric circles. So concentric circles have the same center, and looking up here, those don't have the same center, those don't. None of these really have the same center. See, this is a little smaller than down here. So none of the circles on this page that I'm looking at right now are concentric. Tangent, again, we said they touch in exactly one spot. So if they touch in exactly one spot, well, these would touch in one spot right here. These touch in 2 spots, so they're neither, and these touch in 1 spot as well. So these 2 would be this A would be tangent. C would also be tangent. And then B is neither because it touches in 2 spots. Example 3 here says draw common tangents. So tangents, remember, are going to be lines that touch in exactly one spot. Really, tangents could be rays or line segments as well, but we're going to just do lines for these example problems. It says tell how many common tangents the circles have and draw them. So looking at A here, these 2 circles touch in exactly one spot. So the first common tangent would be right there. That line would touch both those circles in one spot. And then when they touch in one spot like this, or when they have this really orientation, there's going to be 2 more. They're going to be something like, see if I can draw this accurately. It's not real easy with my stylus. There's going to be something like this that touches here and here. And then there's going to be another one over here that touches here and here. So this circle would really have 3, or these 2 circles would have 3 common tangents. Let's look at B here. Now if you look at the middle, I couldn't draw a line right through here because it would touch in 2 spots, but I could still draw that line that comes right here and another line that comes right through on the side over here. So this one is just going to have 2 common tangents. I'll do my best to draw those in for you here. One would look something like that. It's not fabulous. This should just touch in one spot there and there. And then the other one would look something. That's a little better. Something like that. Touch here and here. So 2 common tangents. 2 lines that touch in exactly one spot. I'm going to erase that one and try and draw it a little bit better here for you. Okay, so that one looked pretty decent. That's a little bit better. So there would be my two common tangents. This next one here, those two circles, they're not concentric because they don't share a middle point, but it looks like they would just touch in one spot right here. So we would have one tangent that they both touch like that. So we could say one common tangent. Try the on your own here, and then let's see how you did. Okay, so for this first one right here, the circles don't touch at all, so they would have no common tangents. And we wouldn't call them concentric because, like I said before, it looks like this spot is smaller than over here. This looks like it's larger, so it doesn't look like they would share a center point. The next one here, okay, well, these two don't touch in the middle. Okay, so there's not going to be a line going like this, but we could draw a line here and here, just like we did for the pictures up above. So I'll try and draw those in nicely for you. So there would be one tangent. And there would be my second tangent. Imagine that being a straight line that touches in two spots, touches each of those circles. Now, when the lines look like this, though, when they have a little bit of separation to them, you're also going to find that you could draw a line that comes down through the middle that touches both, and another one that comes through the middle that touches both right here. So let me try and sketch those in for you as well. It would be something like this. And then something like that. So this picture would actually have 4 common tangents. So these are ones really, to remember these, the best way I think is just practice them. Practice them so you get it stuck in your heads what the tangent lines are going to look like depending on the orientation of the two circles, depending on how they're touching or not touching. So let's look at Theorem 10.1 here. So Theorem 10.1 says in a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. So what this is basically telling us is all these tangent lines, they're going to be perpendicular to our radius. If they're not perpendicular to the radius, they're not tangent lines. The line would be moved just a little bit so it would touch the circle in more than one spot. So the only way for it to be tangent is for the line to be perpendicular to the radius. So example 4, verify a tangent to a circle. Says in the diagram, segment RS is a radius of a circle, so we know that's true, it is a radius. Is segment ST tangent to circle R? Use the converse of the Pythagorean theorem. So we want to know, is this a right triangle? Okay, so basically this 26 is meant to be this whole entire side here. So is it a right triangle? We're going to use our Pythagorean theorem. So is our hypotenuse squared, so 26 squared, is that equal to our legs squared and then added together, so 24 squared plus 10 squared? Is that true? That's what we need to figure out here. So 26 squared is 676. And then 24 squared plus 10 squared, that's also 676. So because the two sides are equal, if you think back to a couple chapters ago, since we know those two things are equal, we know it's a right triangle, and therefore we know that segment TS is perpendicular to segment RS. So we can say, yes, segment ST is tangent. Okay, let's look at the next page here. All right, now looking at this problem, these two pictures are a little bit different. It says in the diagrams, segment RS are radii of the circles. Is ST tangent to the circles? So looking here, we know RS is 5, and this is going to have to be the hypotenuse of my circle since this is a right angle. Well, this 8 can only go here because this side cannot all be 8 if this side is 12. So this is 5, and this little piece is also going to be 5 here. So with this little piece being 5 as well, we know that this whole entire side up here is really 5 plus 8, which is 13. So, is ST tangent to the circles? Well, is our hypotenuse squared, so 13 squared, equal to, that's what we're looking for, our leg squared plus our other leg squared. Is that true? 13 squared is 169. 5 squared is 25, plus 12 squared is 144. 25 and 144 is 169. So, is ST tangent to the circle here? Yes. Let's try this next one. Okay, so again, looking at my picture, my right angle would have to be here, so this would have to be my hypotenuse. Now that 7 can only go here, because if this is 12, this little piece is also going to have to be 12. So my hypotenuse here is 12 plus 7, which is 19. That would be my entire hypotenuse. So I'm going to do the Pythagorean theorem. So my hypotenuse squared, is that equal to my leg squared plus my other leg squared? Well, 19 squared is 361. 12 squared plus 16 squared is 400. So that is not equal to each other, so we're going to have to say no, segment ST is not tangent to the circle for that problem. So there's a way that we are going to still use our Pythagorean theorem. The next example here, find the radius of a circle. It says in the diagram, B is the point of tangency. Find the length of the radius. So I would definitely say this is probably going to be one of the trickier problems, some of the trickier examples for this lesson, simply because you have to use FOIL here. So this is in the diagram, B is a point of tangency, so we know this is our right angle. Find the length of the radius. So we're still going to use the Pythagorean theorem, and we're going to say our hypotenuse squared, well, our hypotenuse is 49 plus r, and that squared equals our leg squared, so 7 squared, plus our other leg squared, r squared. Now here's what's going to make this problem tricky. We need to simplify this right here. So 49 plus r squared, well, remember FOIL, that's 49 plus r times 49 plus r. So we're going to do 49 times 49 first, that's 2,401, plus 49 times r is 49r, plus, now we're going to do the inside, 49 times r is 49r, plus, now we're going to do our last, r times r is r squared. So putting this in the right order, we're going to have r squared plus 49r plus 49r is 98r plus 2,401. So this is really this side right here. So I had to use FOIL to find that. So I've got r squared plus 98r plus 2,401. I know I'm not lining up my equal signs as a math teacher. Woo. It bothers me a little bit. Equals 5,929. That's 77 squared plus r squared. Now I want you to notice here we've got r squareds on both sides. So what we can do is cancel them out since they're on both sides. So now we've got a little easier problem to solve. If I move my like terms over by subtracting 2,401 from both sides, I have 98r equals 5,929 minus 2,401 is 36. I'm sorry, it's not 36. It's 3,528. Divide them both by 98. And r equals 36. So there's my radius. Let's try this next one. Okay, it's the same problem. It says K is a point of tangency, so we know this is our right angle. Find the length of the radius. So my hypotenuse, or my radius, or my hypotenuse actually, That's going to be r plus 32, the quantity squared. I could have put 32 plus r, either way, equals my leg squared, so r squared plus my other leg squared, 56 squared. So if I go through and use FOIL on this, I have r plus 32 times r plus 32. So my first, that's r squared plus outside would be 32r. Inside would be 32r. And then last, 32 times 32 is 1024. So really, I've got r squared plus 64r plus 1024 equals r squared plus 56 squared is 3,136. I've got r squareds on both sides. I'm going to cancel them out. I'm going to try and get my r alone now by subtracting 1024 from both sides. So I have 64r equals 2,112. If you divide both sides by 64, then you find that r is 33 for your radius. So definitely, I would say the trickiest problems for this lesson. Let's look at Theorem 10.2 now. Okay, so here is Theorem 10.2. It says tangent segments from a common external point are congruent. So if we have two segments that are tangent to the same circle, and they're both coming from a common external point, then we know those two segments are going to be congruent to each other. So this makes it really easy to set up some problems. For example 6, it says find the value of x. Well, since here's point Q, and we're going to assume these two segments are tangent, we can say these two are congruent. So we can say 3x plus 5 equals 32. Then solve it. Subtract 5 from both. So we have 3x equals 27. Divide them both by 3, and x equals 9. So there's my value of x. The directions just said find the value of x, so we did that right here. On your own for number 6, again, find the value of x, and since these two share this common endpoint r, we know these two pieces are equal, so we're going to say x squared equals 49. To solve it, we're going to say the square root of both. So x equals positive or negative 7. But since we're having the length of something, you're not going to have the length equal to a negative number, so x equals 7. All right, this is the end of Lesson 10.1. Make sure if you have any questions, you ask me about them in class, and have a great day.